Yes. So see the first question. The nucleus XZA emits an alpha particle with velocity v. The recoil speed of the daughter nucleus is. So here we need to calculate the recoil speed of the daughter nuclei. So here one nucleus is given, that is XZA, which emits alpha particle with a velocity v. So here, what is the recoil speed? So for that nucleus, when the alpha particle hits with velocity v, what is the recoil velocity? Means what is the return velocity that we need to calculate here? Okay. So here, according to the law of conservation of linear momentum, see, here we know that the conservation of momentum states that is momentum before collision is equal to the momentum after collision. So here the statement is what? Moment of before collision is equal to moment after collision. As we know that the momentum is expressed in terms of m into v. Momentum is expressed in terms of m into v. Suppose for the initial velocity, here what happens? Initially the nucleus is there. Yes, so the nucleus initially, this is at rest. So therefore here the initial momentum will be 0, which is equal to the after momentum. So after momentum of the daughter nuclei we need to write. So mdvd is the momentum of the daughter nuclei plus m alpha v alpha is the momentum of the alpha particle, right? So before collision the momentum is 0. After collision it is sum of the momentum of the daughter nuclei plus the alpha particle. Here, as I told you already, d and alpha stands for, d is for the daughter nuclei, alpha is for the, that is alpha particle. Okay, so as we know that here this step 0 is equal to, here the mass of the daughter nuclei. So when the alpha particle for the that is nucleus, so for the given nucleus, when the alpha particle hits, the mass will change. The mass will be minus of the initial value. Mass number will be decreased by 4. So therefore here mass we are writing it as a minus 4 into velocity is vd plus. So here for the alpha particle the mass will be 4 and its velocity is given as v in the question. Here we need to calculate the velocity of the daughter nuclei. So for that transfer this. So this will be minus 4v and a minus 4, it will come in the denominator. Therefore it is a minus 4. This is the velocity of the or speed of the daughter nuclei. Here the negative sign. So why we are getting the negative sign here? This negative sign indicates that is the recoil. So here suppose this is the particle, the alpha particle hit and the return of that particle takes place. So this is the return velocity. So it is in the negative opposite direction. Therefore here minus sign will come. So the negative sign shows the recoil of the daughter nucleus. Okay. Therefore option B is the right answer. So if any doubt is there in any of the steps, you can ask. Otherwise, copy down. We will go for the next question. Okay, going for the next question, students. See, a radioactive substance emits 100 beta particles in the first 2 seconds and 50 beta particles in the next 2 seconds. Okay, so here the beta particle, it emits 100 beta particles in the first 2 seconds and 50 beta particles in the next 2 seconds. What is the mean life of the sample? So here we need to calculate the mean life of the sample. So very simple expression. See here, as we know that the relation between mean life and the half-life. So the relation between mean life and the half-life is given by mean life is equal to T half upon ln of 2. So ln of 2 is written as it is 0.693 and T half, that is for the 100 beta particles, it is taken 4 seconds. For the 50 beta particles, it has taken 2 seconds. Therefore, it is 2 divided by 0.9693 seconds. That is option C is the answer. So very simple question. So the radioactive substance emits 100 beta particle in the first 2 seconds and 50 beta particles in the next 2 seconds. So what is the mean life of the sample? So the relation between mean life and half life is given by mean life is equal to T half upon ln of 2. So ln of 2, the value is constant. So ln of 2, we can write it as 2.303 into log of 2 value. So multiply ಮಾಡಿದ್ರೆ 0.693 ಬರುತ್ತೆ. Okay. So therefore option C is the answer. Moving towards the next question. Yes, see. Which one of the following is not correct? Which one of the following is not correct? In forward biased condition, diode conducts. If the packing fraction is negative, the element is stable. Binding energy is the energy equivalent to mass defect. Radioactive element can undergo spontaneous fusion. So which is not correct, you need to tell. Yes, think and tell me which is the right. Yes, which is not correct. So option D, that is radioactive element can undergo spontaneous fission. Okay. So option D is the wrong statement. Remaining all are correct. Yes. Why nobody is answering? So maybe nuclei is not completed in your regular syllabus, but during March, April, May, we have completed this one, right, students? Okay. So the next question. Say this. A and B are the two radioactive elements. The mixture of these elements show a total activity of 1200 disintegrations per minute. The half-life of A is 1 day and that of B is 2 days. What will be the total activity after 4 days? Here given that the initial number of atoms in A and B are equal. Yes, see here. A and B are the two radioactive elements. So, nimatra radioactive element ide. One is named as A and the other one is named as B. So, you have two radioactive elements. The mixture of these elements show a total activity. So, this A is having the activity of 1200 disintegration per minute. So, both are having the same. The half-life of A is, so the half-life, T half of A is 1 day. Okay, and that of B is, it is 2 day. So for the B particle, it is 2 day. What will be the total activity after 4 days? So Yaldudurdu activity 1200 disintegration per minute there, but half life is different. For A it is 1 day and for B it is 2 days. Hagadre, what is the total activity? What is the total activity after how many days they are asking? After 4 days they are asking. The initial number of atoms in A and B are equal. So initially A and B are equal. Okay. So see how to do this one. Yes. See, they are saying option D. So how to simplify this one? That is 150 disintegration per second. Let us see this. So already question I have explained you. You have two elements and its activity is 1200 disintegration per minute. Its half-life is given. So what happens after 4 days? Let us see this one. So as we know that yes. So here we know that T half is equal to 0.693 divided by lambda. Okay. So this lambda is equal to lambda is the that is half-life. T is the half-life. So lambda is disintegration constant. So it is 0.693 upon T. So for a particle, a lambda is equal to 0.693 upon 24 into 60. Because T T they have given it as 1 day for a particle. So therefore 1 day means it will be 64 into 24 into 60. Right. So 24 hours will be there, 60 minutes will be there. Therefore, 1 day can be written as 20 into 24 into 60. Similarly, for B particle, we can write it as lambda is equal to 0.693 divided by 24 into 60 into 2. Because for B particle, it is given as 2 days, right? So copy down this much. Then next activity can be written as. So as we know that activity can be written as yes. So as we know that activity can be written as activity is equal to that is n into lambda. So here for A and B particle, we can write it as n naught into lambda A plus n naught into lambda B. Okay. So here A, the total activity is given as that is 1200. Okay. So 1200 disintegration per minute they have given. So which is equal to n naught will be common. So n naught ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ lambda A value, lambda B value we have. So further just simplification ಮಾಡ್ಬೇಕು ಇಲ್ಲಿ students. So how to simplify this one? ಇಲ್ಲಿವರೆಗೆ ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ, otherwise further simplification you can try this one. So simplification ಮಾಡ್ತಾ ಹೋಗಿ and check what answer you will get. So here inside the bracket LCM you need to take. Yes, try this one further. Yes, how much you are getting for N naught? Simplify madidra students. How much you are getting for N naught? 16623.37. Yes, remaining students. So here you can say that, okay, so N naught calculate madi. Further steps I'll tell you. For a particle in 4 days they are asking. So in 4 days they are asking. So here in the question you just see here what they are saying. See in the question what it is specified. The half-life of A is 1 day. The half-life of A is 1 day. In 4 days they are asking. In 4 days they are asking. So 4 into 1 will be, it is 1. Right. So similarly for B particle, it is 2 days they have given. It is given as 2 days. So therefore for 4 days how much it will be? It will be the half-life of B particle will be 2. The half-life of B particle will be 2. Yes, everybody is getting okay. N1 you are saying. Yes. So half-life of A particle is given as N1 is equal to N naught upon 2 raised to 4. Okay. So it is 2 raised to 4. So 2 raised to 4 means N naught value first you simplify madi. How much you will get? You need to check that one. Then next, similarly for N2, for B particle, it is N naught upon 2 raised to 4. It is N naught upon 2 raised to 4. So once you get the value of N naught, simplification will be easy. So this is 2 raised to 2 agate because for B particle, the half-life is 2. So therefore, N naught value bandmele, here what you can do, N naught upon 2 square, and here it is N naught upon 2 raised to 4. So just check N1 value, N naught value, and N2 value. All the 3 values you check. Next step, I'll tell you what to do. The question is little lengthy. So especially NEET exam, you may get this type of questions. So therefore, the new activity can be written as, here the new activity can be written as, because they are asking what is the new activity, right? So therefore, new activity A1 is equal to, now it is N1 into lambda A plus N2 into lambda B. So if you don't simplify N1, N2 also, it's fine. Here also you can do the simplification. So here N1 value is N naught upon, it is 2 raised to 4 is 16 into lambda A plus N2 value is N naught upon 4 into lambda B, right? So therefore, the new activity can be written as, but N naught value is mandatory. So N naught value ಯಾರಿಗೆ ಬಂದಿದೆ ನೀವು ಇಲ್ಲಿ further steps ಅನ್ನು simplification ಮಾಡ್ಕೋಬಹುದು. Okay students, otherwise you do one thing. So ಇದೆಲ್ಲ ತುಂಬಾ confuse ಆಗ್ತಾ ಇದ್ರೆ, so instead of that you follow one step. That is, here what I told you, that is lambda values. So already nimatra lambda A value ide. I'll not write that values. So lambda B value ide. Better you simplify this quantity and this quantity. Right? So if you simplify these two quantities, N naught is equal to, already I told you the simplification. So adra prakara N naught value ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡ್ಕೊಳ್ಳಿ. Right? Now here the N1 is equal to, it is N naught upon 16. Similarly, N2 is equal to, it is N naught upon 4. But they are asking you to calculate the new activity. The new activity will be, so N naught nimge ಏನು ಬಂದಿರುತ್ತೆ ನೋಡಿ, N naught into lambda A value already I told you to calculate. This divided by 16 plus N naught into the lambda B value upon 4. So just check the answer whether you will get option D. I think so you may get 500 disintegration per second. Yes, later you just go through this calculation. So calculation is little lengthy. Please go through it later. Right? So hope so the step 2. I'm going for the next question. H1, 2. And the helium atom is, it is He24. Both are having the binding energy per nucleon as 1.1 mega electron volt and 7 mega electron volt. So deuterium is having 1.1 mega electron volt and helium is having 7 mega electron volt. Okay. If the two deuterium atoms fuse to form a single helium atom, then the binding energy released is, so here energy per nucleon of deuterium and helium is given as 1.1 and 7 mega electron volt. So if the two deuterium and the L hydrogen atom fuse to form a single helium atom, then what is the energy released you have to calculate. Yes, so you can see here students how to simplify this one. So as we have the binding energy of deuterium is given as that is 1.1 mega electron volt. So for the deuterium, the mass number is 2. So per, in the question, see here, they have given it as what? That is energy per nucleon kottidare. Hoda. So energy per nucleon kottirodrinda, what you do? Energy per nucleon. So this is having 2 nucleons. So therefore 2 into 1.1 will be 2.2 mega electron volt. This is for the hydrogen. Similarly, for the helium, you calculate. So for the helium, this is 4 into 7 anta helidare. So 7 4 it is 28 mega electron volt. Further, what they are saying, the two deuterons are combining to form a helium nucleus. A helium nucleus. Here the energy is released. Okay, so this is equal to the binding energy of helium minus 2 into binding energy of deuteron. So therefore this is equal to binding energy of helium. So binding energy of helium, it is given in the question, that is 28 minus 2 into binding energy of the deuterium. So deuterium means it is 2.2. So 28 minus 2 into 2.2. If you simplify, 28 minus 4.4. So 28 minus 4.4 will be 23.6 mega electron volt. So it is 10 to the power of 6. Copy down this one. If completed, please tell me. We'll go for the next question. Okay. Answer is option C. Next question, students. See, the relation between half-life and the decay constant. So this is very simple. Directly you can answer this. The relation between half-life and the decay constant. Already in the previous questions, we have used that one. How that? So tell me, what is the relation? A. A is the right answer. So we have the T half is equal to ln of 2 by lambda. So ln of 2 can be written as, that is log of 2 upon lambda. That is T into lambda divided by log of 2. So option A is the right answer. Okay. Next question. A radioactive decay can form an isotope of original nucleus with of particles. Yes, radioactive decay can form an isotope of the original nucleus with the emission of alpha particle. So alpha particle emit adaga, what will be the changes? 1 alpha and 2 beta, 4 alpha and 1 beta, 1 alpha, 4 beta, 1 alpha, 1 beta. ಸೊ ಐಸೋಟೋಪ್ ಫಾರ್ಮ್ ಆದಾಗ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಏನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ? ಸೊ ಇಟ್ ಇಸ್ ಆಪ್ಷನ್ ಎ ಸ್ಟೂಡೆಂಟ್ಸ್ 1 alpha and 2 beta particles. See here, as the emission of an atomic number by 1, but mass number remains the same. So the emission of the 1 alpha particle and 2 beta particles from the nucleus can form an isotope of the original nucleus. So it is represented as x of az, which gives alpha decay. So that is Z there is decrease in 2, and for a value there is decrease in 4. Then further 2 beta particles, which will give you the AZA minus XZA minus 4. The time taken between 50% decay and 87.5% decay of the substance will be. Yes, the half-life of a radioactive substance is 20 minutes. Okay, the time taken between 50% decay and 87.5% decay the substances. See how to simplify this one. See here, let in the time t1. So I assume that in the time duration t1, 50% of the substance decay, and in the t2 time, the 87.5% of the substance will decay. Then in time t1, 50% of the substance is left out. Howda? So in 50% decay ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ in the same time interval, how much percent is remaining? 50% it is remaining. And here in the same time duration, how much it is remaining? That is 12.25% substance is left over, right? Here, according to the decay law, we have n is equal to n naught e raised to minus lambda into t, where lambda is the decay constant. So therefore, we can write it as n upon n naught is equal to e raised to minus lambda into t. So here n is 50 upon n naught is 100, which is equal to e raised to minus lambda into t1. Okay. So here if you simplify, it will be 1 by 2, which is equal to e raised to minus lambda into t1. This is our equation 1. Similarly, for the second one, it is 12.5 upon 100, which is equal to e raised to minus lambda into t2. So here this simplification will be 1 by 8 is equal to e raised to minus lambda t2. This is our equation. So whole consider means initially disintegration is first. So after disintegration, 50% is remaining. So total 100%. Same with the second case, second substance. Hope so equation 1 and 2, it is clear to everyone. So next is what you need to do? 2 divided by 1. So you do 2 divided by 1. See, when you divide 2 divided by 1, here the simplification is, that is, it is 1 by 8 upon 1 by 2, which is equal to e raised to minus lambda into t2 upon e raised to minus lambda into t1. So therefore here this will become 2 by, that is nothing but 2 ones are 2 fours are 8. Therefore is 1 by 4 is equal to, plain agate 1 by 4 is equal to e to the power minus lambda into bracket t2 minus t1. Not understand calculation, please tell me. Illodi. Here it is equal to e raised to minus lambda t2 minus t1. So idain exponential ide. If you transfer it on the other side, this will be taken as ln. This will be taken as ln function. Okay, so here this will become ln of 1 by 4. It will become ln of 1 by 4. But ಇಲ್ಲಿ minus lambda t2 minus t1 ಇರೋದ್ರಿಂದ what I'll do, I'll interchange this one. So here I am going to write it as lambda into bracket t2 minus t1 is equal to ln of 4 ಆಗತ್ತೆ. So 1 by 4 ಇದೆ. So if you interchange that, ನಾವೇನ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ, this lambda function. So this lambda function we are minus ಇರೋದ್ರಿಂದ we are interchanging. Minus sign ಅನ್ನ eliminate ಮಾಡ್ತಾ ಇದೀವಿ by rearranging the terms like this. Right? So therefore t2 minus t1 is equal to, students, it is ln of 4 divided by lambda. So ln of 4 can also be written as 2 ln of 2. ಯಾಕಂತ ಅಂದ್ರೆ ln of 2 square ಅಂತ ಬರಿಬಹುದು. ಸೊ ನೀವು log ಫಂಕ್ಷನ್ ಅನ್ನು ಆಲ್ರೆಡಿ ಕಲ್ತಿರಬಹುದು ಅನ್ಕೊಳ್ತೀನಿ. ಸೊ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಇದ್ದಾಗ ನಾವು ಯಾವ ರೀತಿಯಾಗಿ ಬರಿತೀವಿ, we have, yeah, that is log of n to the power p can be written as p log of n. ಅದೇ ರೀತಿಯಾಗಿ ಇದನ್ನ 2 ln of 2 ಅಂತ ಹೇಳ್ತೀವಿ. Divided by it is lambda. Divided by it is lambda. So which is equal to 2 ln of 2 upon, here it is t2 minus t1 is equal to. So divided by lambda is there. Lambda is nothing but the formula is ln of 2 upon t half. It is ln of 2 upon t half. So now we can cancel this ln of 2. Ln of 2 we can cancel. Therefore we will get 2 into t half is equal to t2 minus t1, and t half is 20 minutes. Therefore this is 2 into 20, that is nothing but 40 minutes is the answer. 40. Solution or question. If any doubt is there in any step, you can ask. If completed, tell me. Okay, no doubts. See the next question. A nucleus at have in the ratio of 1:2. So here a nucleus is there, it's the ratio. So this ratio 2. Their velocities are in the ratio of. So what is the ratio of their velocities? Yes. This is the velocity ratio. So let A1 and A2 be the mass number of the two nucleus. Therefore, as we know that the radius is written as R1 is equal to R naught A to the power 1 by 3. So this is equation 1. R2 is equal to R naught. This is A1 for second part, A2 raised to 1 by 3. This is second. Okay. Now, so dividing equation 1 by 2. So when I divide equation 1 by 2, this will be R1 upon R2 is equal to. So R naught will get cancelled. Therefore, we will have A1 upon A2 to the power of A by 3 to the power of a by 3. So when I rearrange this one, it will become r1 by r2 cube is equal to a1 upon a2. Okay. So here in the question itself, it is given as r1 by r2 ratio is given as 1 by 1 equal to 1 upon a2. What is 1 by 2 cube will be 1 by 8, which is equal to a1 upon a2, right? Hence the ratio of their masses, is taken as 1 is to 8. Therefore, m1 by m2 is equal to 1 upon 8. So according to law of conservation of linear momentum, students, we have, because namu velocity ಬೇಕಾಗಿರೋದ್ರಿಂದ ನಾವು ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, otherwise velocity find out ಮಾಡ್ಲಿಕ್ಕೆ possible ಇಲ್ಲ. So according to conservation of linear momentum, the momentum before collision is equal to the momentum after collision, right? So velocity ratio andre it is v1 by v2 is equal to, it will be m2 by m1. So m1 by m2 1 by 8 irodrinda it will be 8 by 1. So answer is 8 is to 1 or 8 by 1. Option C. Copy down.
Geometry.
See the next one. The radioactive sample of half-life 10 days contains 1000x nuclei. Number of original nuclei present after 5 days is. So the nucleus present after 5 days you have to calculate. The radioactive sample of half-life is given as 10 days and it consists of 1000x nuclei. Number of original nuclei present after 5 days. Yes? Completed question. See, students, the half-life is given as 10 days. Initial number of nuclei. So, initial number of nuclei ಎಷ್ಟಂತ ಹೇಳಿದರೆ, they have given it as n0 is equal to 1000 into x. So, t is equal to how much it is? It is given as 5 days. And we have the t half is equal to ln of 2 upon lambda. So, that is lambda is equal to ln of 2 by t half is given as 10, right? So according to the disintegration formula, this is n is equal to n naught e raised to minus lambda into t. So that is nothing but n naught e raised to minus. So lambda is ln of 2 upon 10 into 5. So that is n naught e raised to minus. So this is 5 ones are 5 twos are. Therefore, it will be ln of 2 by 2. Right? So therefore, this is n is equal to n naught e to the power. So here this 2 by 2 can be written as root 2. So therefore, we can also write it as minus ln of root 2. Okay, so to avoid the negative sign, we can also write it as n naught e is to ln of 1 by root 2. Ln of 1 by root 2. So therefore, here n of t is equal to n naught divided by root 2. So n naught is given as 1000 into x upon root 2. So if you simplify, 1000 by root 2 will be 707 into x. So option A is the right answer. Yes, copy down. Okay, the next question. See, an element X decays into element Z by two-step process. So that is X gives rise to Y, and here the equation means this process is given as X is giving out the Y nucleus plus helium plus that Y integrate into Z plus 2 electrons. Then X and Z are the isobars, X and Y are the isotopes, X and Z are the isotones, X and Z are the isotopes. So if you know the definition of isotope, isobar, isotones, everything, you can answer this one. Yes, tell me what is the answer. B, D. It is D, that is Z and X have the same number of protons. So they are isotopes. Okay. Option D is the answer. Last question for the today's class. See this one. A nucleus of mass 20 gamma photon of energy 6 mega electron volt. If the emission assumed to occur when nucleus is free and at rest, then the nucleus will have kinetic energy nearest to. The nucleus will have kinetic energy nearest to. So 1 U is equal to, you have to take it as 1.6 into 10 raised to minus 27 kg. Mass is given as 20 into U, emits a gamma photon of energy 6 mega electron volt. If the emission assumed to occur when the nucleus is free and at rest, then the nucleus will have kinetic energy nearest to. See, so as we know that kinetic energy is equal to half mv square. So here the m is given as 20 into u. Yes, here that is 6 into minus 13 joule. So why it is written like this? Because it is conversion ಆಯ್ತಾ. So ಇಲ್ಲಿ convert ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ energy ಅನ್ನ joules ಅಲ್ಲಿ. So to convert energy into joules, that is E is equal to 6 mega electron volt. So 6 into mega means 10 raised to 6. Electron means it is 1.6 into 10 raised to minus 19 joule ಆಗುತ್ತೆ. So therefore it is 6 into 1.6 into 10 raised to minus 19, and this is plus 6, so it will become 10 raised to minus 13 joules. So using the conservation principle, so that is the initial momentum is 0, so which is equal to mv plus ey upon c. Okay, so therefore the v value is written as minus e upon m into c. So e value we have here 6 into 10 raised to 6 into 1.6 into 10 raised to minus 13. Aita, then next m value is given as 20u. So therefore adanna kuda convert ಮಾಡ್ಕೊಳ್ಳಿ 20 to 6 into 10 raised to minus 27. C value, the velocity of light in the vacuum is 3 into 10 raised to 8. So therefore this will be minus 5 meter per second. But nimge kinetic energy kelodrinda it is half mv square. So this is equal to half m value is, that is 20 into 1.6 into 10 raised to minus 20, and the value is 10 raised to 5 to the power of 2. So simplify, you will get 16 into 10 raised to minus 17 joules. But options alli electron volt alli kottirodrinda, what you need to do, you need to divide this answer by 1.6 into 10 raised to minus 19, 10 raised to minus 19. Okay, again here kilo electron volt ಅಲ್ಲಿ ಇದೆ ಹೌದಲ್ಲ. So kilo ಅಂದ್ರೆ 10 raised to 3 ಆಗತ್ತೆ, and into 10 raised to minus 19. So this will be how much? 10 raised to minus 16, right? This is, so therefore the answer is 1 kilo electron volt. Simple ಆಗಿದೆ, MCQs ಅಷ್ಟೇ difficult ಆಗಿರುತ್ತೆ. If you know the theory properly, you can answer, students. Copy down this. We will do the next question in the next class. Copy ಮಾಡ್ಕೊಳ್ಳಿ. If any doubt is there, you can ask.